Just started my video. Hello, this is Miss Moreland. We're going to go through page 1 of the review. I hope this goes smoothly. I'm writing on a new tablet, so it might take me a little bit to get used to it. So bear with me. Alright, so we're going to start with these first ones that are general transformations. So you just have to state what happens. So on the first one, you should have written up 1. Second one, since it's on the inside with the X, it's the opposite, so it's going right 4. This one's a little tricky, but anything inside is going to be horizontal. And remember, inside parentheses, it's the opposite. So this is actually a horizontal shrink. Okay, which means if you were going to find this, you would actually divide all the X values by 2. Outside is always going to be vertical. In this case, it's a vertical stretch. Okay, this one's going down 2. This is a reflection, and since it's excluded, it's over the x-axis, so outside is x-axis, so it's reflect the x-axis. Inside, remember, you're going to be using the word horizontal, and it's the opposite, so if it's on the bottom, it's really a horizontal stretch. This is outside, so it's going to be vertical, and since it's a fraction, it's actually a vertical shrink. Okay, inside with the X in parentheses, it's going left 3 because it's opposite. And again, the one above this, it was reflected over the X-axis because it was excluded, or outside. If it's inside, it reflects the Y-axis. Right, next ones are still general. If I have y equals x squared, or really any function, if I replace x with x plus 3, it's going to the left 3. If I replace x with 4x, that means it's a horizontal shrink, because remember, anything inside is horizontal and it's the opposite, so it's a shrink. And this one's the tricky one. It says y minus 1. Remember, if you were going to plug that in for y, you'd want to add 1 to both sides. So this one's really going up 1. It's always opposite when it's inside parentheses. Alright, now it says list all the transformations. So right here I have 2 things going on. The negative means it reflects. Since it's outside, it's reflecting the x-axis. And the 2 gives me a vertical stretch. Inside, I have 2 things going on. It's going to the right 1. And the 5 is a horizontal stretch. And then the last thing is it's going up 3. So I have 1, 2, 3, 4, 5 different transformations happening to that one function. Okay, remember again, outside, oops, I flipped the slide too soon. Remember again, outside is always vertical, inside is always horizontal. When it's next to the x being added or subtracted, it goes right or left. When it's outside of everything being added or subtracted, it goes up or down. Right, now we're going to get to some general ones. So you should have written the words down 2. So you're going to take each one of these points and shift it down 2. And then connect it. So there's my transformed graph. This one is going right 3, so I'm going to take each point and shift it right 3. And connect it. The whole graph is shifted right 3. Right, this one, oh, that's a repeat. This is a horizontal shrink, which means I'm really dividing the x values by 2. So this one was originally -4, it's now going to be at -2. This x value is 0, it's going to stay there. This one was originally 2, divided in half, I get 1. This was originally 3 to the right, now it's going to be at 1.5. So I connect it and get it to work because my tablet is being a little frustrating. And I can see that now my graph is compressed horizontally. It's squished together in the horizontal direction. Alright, now I look over here, and this 2 is outside, which means it's got the word vertical. In this case, it's a vertical stretch. So what I'm doing is taking the y values and timesing them all by 2. I can read that. So that means this one was originally at -2, so it's now going to be at -4. This was originally at 4, so it's now going to be at 8. 1, 2, so 4, 5, 6, 7. Goes a little off my graph. This one was at 4, it's now going to be at 8, a little off my graph. And it hasn't gone up or down at all, so it's going to stay the same. Connect it. All right. We're just going to use some straight lines here. Connect it, reuse straight lines. Again, I'm still writing on this new tablet, so it's going to be a little tricky. Right, so there's the last couple. Right, and these two aren't too bad. Right, this one up here to start. I get my mouse moving in the right direction. This is going left 1, down 3. So I'm going to take each point, go left 1, down 3, left 1, down 3. And connect them. They aren't going to be connected very nice. Yours should look a little nicer than mine. But there's my generic function. Alright, and this last one has to do a two-stepper. I have to reflect over the x-axis. And I have to shift it up 2. Now remember, we have the acronym please remember to do, which means I have to identify my parent function, which in this case I don't have one, it's just a generic one. Then I have to do the reflection. So to reflect this over the x, it's 2 away from the x-axis, which means I need to go 2 on this side. It's 4 away, so I'm going to go 4 this way, 4 again, and 0 is not going to move. So I flipped this whole function over the x-axis. So I've covered the reflection. Now I need to do the translation. So the translation means it's shifting up 2. So now I shift each one of those new points up 2. So my final function is the red function. Right? So please remember this acronym down here. Please remember to do. You have to do your parent function, your reflection, your translation, and then your dilation. Speaking of that, we're now going to move on to parent functions, but I'm going to start a new video, so watch the next one if you want to see this.